Okay, let's go to our third video of the theory of hypothesis testing. So in our third video, I'm gonna talk about two topics. The first one is variance testing. And for variance testing, we have two types. One is one sample variance testing, and the other is two sample variance testing. This is the first topic of today's lecture. The second lecture is two sample testing for mean. Okay, so let's first take a look at variance testing. So for variance testing, we first talk about one sample variance testing. And we begin with one-sided, one sample variance testing. This is right-sided, one sample variance testing. And we assume the model is normal model or non-normal model but enlarged. And sample variance is utilized in variance testing. Recall, sample mean x bar is utilized in mean testing. And recall that this is the key. We only care about the equal sign in H null. What do I mean by this? So H null is true in the sense of hypothesis testing. Can be simplified as the equal sign in H null holds. Then, under H null, in this single-sided hypothesis testing, which is sigma squared, smaller or equal sigma 0 squared, we just care about the equal sign we have test statistic modify on sample variance kept S square. So for capital S square, remember that we have this famous property n minus 1 capital S square divided by population variance. When h null is true, we only care about the equal sign h null, so this is sigma 0 square. It follows chi-square with degree of freedom n minus 1. And we utilize this test statistic, this whole thing, to talk about p-value, decision rule, and power for this single-sided variance testing, one sample variance testing. So for p-value, this is the probability of n minus 1. So for p-value, we always use small s square, not capital S minus square, divided by sigma 0 square, greater than chi-square n minus 1. So chi-square n minus 1 here, it is a random variable, following chi-square n minus 1 degree of freedom distribution. This is the p-value for one-sided one-sample variance testing. Next is decision rule. So for decision rule, we just want to compare s squared with some constant c. So n minus 1 times constant c divided by sigma 0 square greater than chi-square n minus 1. This is a random variable following chi-square distribution with degree of freedom n minus 1. And we cite this probability as alpha. This is decision rule. So for power, so consider sigma square is not equal to sigma 0 square, for sigma star square from the previous space of alternative hypothesis. What is the power function? So the power is just n minus 1 capital S square, not small, sigma star square. So this thing itself